Welcome to my Only One Outlier podcast show, where I'll be exploring the data science career tips with the industry experts who can share their experience and journey with us. I am your host Nirmal, from a new grad to an early career data scientist, from a data analyst to a data engineer, or anyone who wants to start or transition their career into data science. We will bring you all the do's and don'ts to help you guide in your data career path. Welcome, everyone, to my Only One Outlier podcast show. Today, I'm excited to welcome Maria to my show. She is data and AI leader with 12 plus years of experience, deeply focused on MLOps. And that's where I think I first came to know about her and her contents in the YouTube. And I have learned myself a lot about MLOps, how to put in practice. People talk about it, then they don't have real world examples to implement it, so that is more important. She's been actively working at the intersection of LLM ops, and today we call it Gen AI, the LLM. So it's kind of started from DevOps, CI/CD pipeline. How do you set up? How do you run it? She has done it all and mastered it all. She's currently co-authoring a book as well, I believe, and then we'll kind of touch upon some of this stuff in a little bit deeper. Thank you so much, Maria, for coming to my show. I welcome you, and I'll let you introduce a little bit more.
Yeah, well, thank you so much for inviting me. Indeed, all of the things you said are correct, except that I'm the only author of the book and it's a
Okay.
lot of work. I wish I had the co-author. It's a lot of work to write a book.
I do.
More
feel
than
it.
I ever expected. And yeah, if you knew what you are getting into, I'm not sure I would would have agreed. But yeah, it's awesome. It's almost coming to an end. In 1 month, I have the final copy that I need to give to the publisher, to O'Reilly, and then from that moment, it's done. So yeah, that's
That's
a great
awesome.
feeling that it's almost there.
Yeah.
Yeah,
Well, that's awesome. I think
yeah.
I did co-author a book, and I know the pressure, like the timeline and everything, and with all the other stuff that you are doing, yeah, it's really hard and kind of commendable on how you're managing the time.
Yeah, indeed. I think managing the time is definitely one of the hardest things to do, especially when you have kids. But yeah, also, I think one of the things you haven't mentioned, we just started a consulting company in November with two co-founders focused on production AI, so how to bring AI in production. And we focus on AI strategy, AI education, and also on consulting, AI engineering consulting. We really believe in these three pillars because you can't really be consultant without educating the team. I don't believe in just come in the team, doing something, delivering, and be done with it. And I think that's also one of the things that is important in AI engineering. I don't think you are ever done
Mm-hmm.
because the models or agents, they only start living when they're in production. And that's where the hardest work comes. And it's very different from what software engineers typically think about delivering software.
Yeah, that totally relatable, like right now I think we are kind of chasing, sometimes I feel like chasing the tail rather than the head, so things like you need to put in place before you think that, hey, AI will fix everything, right?
Yeah.
The engineering drill, I think the engineering foundation still remains the same. So yeah, that's very important. Thanks for highlighting that. So let's jump into some of the things or topics I have prepared, and that will kind of let us know a little bit more about you, your passion, how you get into this field, and what are you doing. Like you briefly mentioned about a startup, maybe we'll touch that also in a little bit. So to begin everything, how you originally pulled into data and ML world, like how everything started for you.
Yeah. Well, I studied econometrics and I don't think I actually ever liked the study on its own, but I did like the math part of it. And also, yeah, I wouldn't call it computer science, but we were using R. It's kind of like a programming language, but
Yeah.
not exactly. Who knows? They would agree. And yeah, I used R for many, many years. And then I was an analyst. I started my job, my career as an analyst in a telecom
Hmm.
company. And back then, the role of data scientist didn't really exist. And my role was also actually building models. It was churn predictions for telecom customers. I think for telecom, churn prediction is one of the biggest things they care about. and also some demand forecasting. And then everything has changed around 2016. Everyone started hiring data scientists, and also the roles within the organization were shifting. And I moved to another team, and I became officially a data scientist. And we built some models related to fraud detection. So people would get phone subscriptions with phone, but they would never pay and just get the phone, and that kind of fraud. That's what we wanted to stop. And then you realize when you build something like that, how do you actually make it useful? And that was hard because no one has ever done that before in the whole organization. There was some software engineering team that did have some APIs, but they also didn't really know anything about models and the skewness of training and serving. So I think that's that's pretty challenging. And that's how I got into MLOps, because there was no one who could do it for me. And also formalize it and teach others how to do the same thing.
Well, that's amazing. Yeah. A lot of things that we build our skills because we had to at that point of time, right?
Yeah.
So yeah, an interesting journey. I think we kind of share some of the common ground. I also started as analyst. Then
Yeah.
I was in the banking doing fraud detections as a part of my data science career transition. So yeah, we also had similar things, right? Like trying to find the engineering support always hard. Their backlog is heavy, and like you mentioned, it's not only those software engineers can help you out with everything you need, not because they're not willing to, but the ML piece itself could be challenging and new to them, and you have to work along with them. So and you automatically start picking up the skills from engineering side,
Yes.
right?
I mean, everything has shifted so many times since then. When we just getting started, there were no tools out there that would do experiment tracking or model registry or serving. Nothing was
Right.
there. So we were building our own tools. And then around 2018, you would see some kind of formalization happening in the field. And then there was also shift more towards using these open source tools, or maybe even buying some software.
Right.
That's also a lot of companies went through this cycle. And then you have this kind of consolidation happening now. You see that a lot of these tools disappear, and then you need to still figure out how do you manage it, right? And it's a challenge. And if you know the principles behind that, I think those matter the most. Those organizations, they do it well.
Right. Absolutely. You touch upon a good point that the shift of the role and skill, right? It's happening over time, even now. And I guess that is how I personally came across MLOps, just like you mentioned, building model on the notebooks. And then if you don't know anything about implementing it, then that's only the half the battle, right? So what are some of the suggestions for the folks who's learning data science today? Most of the times I talk to my mentees, and I like to highlight it from my end as well that, hey, engineering piece, you should not leave it behind. What are a couple of your suggestions that you can probably think of, like, for the new data scientist who is getting in this field?
Yeah. Well, it is complicated. I think the data scientist as a profession is kind of dying in a way. So everyone is shifting towards AI engineering.
Right.
I'm not saying it's completely dying. I think there is definitely a space for regular machine learning models. Those are more efficient for certain tasks. And I don't think it will ever change because of the latency requirements and all of that. So that will become still a part of what people need to be learning. But you definitely need to understand also where you would use AI, as we know now, what applications and where it makes sense and where it doesn't.
Right.
So you definitely need to learn those skills as well, because there is a really big demand for it. I think if I look at a year ago, I was doing mostly ML, and now I'm mostly doing AI. And that's not just a shift in my career, it's shift in everyone's career. And trying to understand how you can apply those principles again for the tools and for yeah for different models that you have in your toolkit today, how would you change the processes around it? So I think that's very interesting time to live.
Yeah, absolutely. And then comes the cost and evaluation of what tools is more efficient for the nature of the work. Can you afford that much of implementation cost? I mean, you can solve a problem in 10 different ways. How do you kind of prioritize your solutions? And this is what I think exactly what you said.
Yeah.
Like if you only think about from data science mindset, you will probably think about, hey, this is the best model with a high accuracy. Does that really mean that the same model, has what are the challenges? It may have explanation challenges, implementation challenges, many things, right? So I think everything as an integrated system needs to be built, and
Mhm.
that's what I think engineering mindset plays a big role, right? In my opinion. So
Yeah. Well, I think not even engineering mindset. I think data science mindset also is very important. It comes
right,
into evaluation, right? Evaluation is a big piece of any modern AI system.
right,
And a lot of teams don't do evaluation that well. Maybe they do it before they deploy things, but not really after they have deployed it, and also not in between.
yeah,
So there is always something missing. And that's really a data science mindset.
yes,
And that's often what software engineers actually miss, I find. And
hmm,
they basically deploy AI systems with ignoring all the hard parts that come with it. And these are the hard parts.
yes, yeah. Evaluation, especially in the today's scenarios where like we are relying on the LLM models output, and there are many things to use and different use case and scenarios, but then it's not like as easy to set up a confusion matrix in the traditional ML world, right? So
Yeah.
it's a little challenging, and these models also kind of every run could be different. They are very probabilistic
Yeah.
models, So,
Yeah. And I think what we see now is that evaluation is not the straightforward indeed, because you first need to define what do you care about. For regular ML models, we kind of know what we are looking for. For classification, for regression tasks, we already have very much established metrics.
mhm,
The same is also established pretty much for recommender systems,
exactly.
which used to be really challenging in the past as well, of the search algorithms. But when it comes to modern AI, we don't have this kind of metrics that are the same for everyone. So every team needs to establish their own metrics they care about. I think that has always been the case for ML as well, because you ultimately care about the business metrics in the end.
Yes.
But here it's even more. You can't do regular evaluation without it.
Yeah. Yeah. Totally agree. All right. So with your background in MLOps so far, if some team or someone is just starting to learn MLOps, right? What are the core principles, or what are the things that defines MLOps? So in your own words,
Mhm.
what is MLOps? Let's
Yeah.
talk about that.
Well, it is a set of practices, just as DevOps, that allows to bring machine learning models or AI in general in production reliably and efficiently. Basically, it's supposed to make the life of data scientist or AI engineer as easy as possible. And also in the future, agents would be able to use it as well. Instead of a data scientist or AI engineer. So I
Hmm.
think that practice also helps towards it at some point later. We are not there yet, obviously. One of the main principles of MLOps is traceability and reproducibility. That's for me the key. And it must be related to everything, to data, to model, to code. And when it comes to AI, it's actually much harder to do everything that way, because a lot of things are not reproducible. Not exactly. Because if you, let's say, use an anthropic model now or use it in 1 hour later, there is no guarantee it's exactly the same model, even though the tag of the model is the same.
Hmm.
So it makes it much harder to actually know what's happening in your system. And that's why evaluation and guardrails must be, even a bigger thing than they used to be in the past.
Yeah. Yeah. Totally agree. I think that is one misconception. Like people think when I talk to like small scale companies or who are like in very much of budget constraints, and they'll say, hey, we can just buy a tool, maybe MLflow or any other tool, and get away with it, right? So but I think there's more than that, right? When it really comes to practicing it to perfection. I mean, obviously the perfection is something we don't get it, but at least
It's very hard.
it's very hard. Yeah, like you mentioned, the reproducibility of things, setting up the right experiments, and all that things matters. Versioning data was not even a concept. Versioning model was a concept. Then people started coming up, hey, yeah, you if you don't version the data, how do you guarantee that same data set was used, right?
Yeah. Yeah, indeed. Those still a lot of teams don't version the data properly.
Right.
I think that's one of the biggest problems. You see that data versioning is kind of common in certain industries where it is obligatory by law, and we will see more of it because of the AUAI Act in Europe. There are also, I guess, similar laws in the US, I guess less rigid as we have here.
True.
But still, you do need to do some kind of tracking of the data, what you're training the model on. You also need to track what kind of predictions you are making and based on what kind of input. And that might be also a requirement for your system. But in general, at any point of time, you want to, debug as much as possible about your system. And that's what you see now for LLM stack. Traceability becomes also a very important thing, which is actually a great concept. Open telemetry, is now used everywhere. You see it in MLflow, in Pydantic AI.
Mm-hmm.
And that's really great. We never had this kind of observability in the past. We were trying to do something with logging, but it's not that great not as easy as you can do it now. I use MLflow quite a lot, and I really like the traceability part in it and how easy it is. If you want to do more granular type of traceability, you still need to implement a lot of things by yourself. Overall, where we are today versus where we were in the past, I mean, it's just such a big difference. And I see a lot of these concepts also being implemented later for ML models.
Right.
Because we never had this kind of traceability in the past. While the logic of the model can be quite complicated, especially when it comes to the manipulation of the data that comes in. It's not always possible to make it part of the model or part of the system. So sometimes we need to manipulate it in certain ways, especially if you want to do some kind of split of the logic, maybe different models for different purposes. And that information, we were logging it in some ways, but it was a bit dirty in a way. And these tools do exactly that. So I think it will also change the way how we do MLOps for regular ML.
That makes sense. Yeah. So you touch upon like there will be a point of time where you decide the available tools, what you can get out of it, and then you also mentioned that I have built my own custom tools, right? So or the feature in your product line. So how do you decide, like if you have some tips for the people, like hey, trying to use MLOps, and then maybe use the tools available, like the cloud vendors also has a Databricks, Azure, everyone has some sort of MLOps then, and it may not be enough for some of the things like you mentioned, right? So any suggestion or your own learning like between these proprietary tools or building your own, right?
Yeah, well, I think today you should not build your own tools. We are not anymore at this stage. In 2016, yes, for sure, you don't have a choice. In 2018, also not that much. But today you do have a lot of choice. Nothing is perfect, obviously, but it's good enough. And if you try to build something yourself as a platform team, it's also never going to be perfect because all your customers come with different kind of requests, and you can't always make them happy. But overall, I think it's important to look at types of tools. So you need version control, like you need it in DevOps for your code. And you need some CI/CD pipelines. And that's also non-negotiable because you need to have standard deployment practices. You also need orchestration. So that's where your data pipelines run, where your model training pipelines run. That's where your deployment pipelines also run. I mean, there are many tools for that. Airflow, step functions, and Databricks. You have Lakeflow jobs and previously Databricks workflows. They change the names a lot of times. You need some model registry. I think for MLOps, it is actually quite important because it also allows you to package your model in a certain way. So MLflow, there is also Comet ML. I think also AWS has its own model registry. You need container registry, most likely. Well, depends actually where you run things. Maybe container is kind of abstracted away from you for certain tools like Databricks. Even though you can use images, it's actually made pretty hard for the users and not possible even with serverless proposition. You need some compute for training, you need some compute for serving. Can be that you use Kubernetes jobs to train your models or Databricks jobs. And those configuration for those jobs would differ depending on your needs. The same goes for serving, right? Depending on what types of models you're trying to deploy and where, because training and serving can be also decoupled from each other, from also even target location where you're trying to deploy them.
Right.
Monitoring is also one of the non-negotiable stacks. I think for regular ML, you can deal with regular monitoring tools that software engineers already use within the organization. Maybe you have a Datadog or Elk Stack, Prometheus, Grafana. Like there are so many options. They don't really do any ML specific metrics. You would have to build it yourself. Or there are tools that provide you ML specific type of monitoring for looking for data drifts, for example, or model drifts.
Right.
Evidently, AI has such options, or you can use Databricks native tools. Data quality monitoring has this kind of options as well. You need some kind of data version control. On Databricks, specifically, Delta Tables is on its own kind of a data version control tool because it has a history and you can travel back in history. And with MLflow, you can log that specific version of the data that you were using for training. So you can actually get that exact version back. You may need feature store. It's, in my opinion, kind of debatable. Do you really need it? Well, depends. If you need to just point in time kind of calculations, feature store really simplifies your life. Or if you need real time online lookups with also this kind of capabilities, it does make your life a lot easier. So I would definitely consider it for those options. You need something for evaluation. For regular ML, evaluation is pretty much straightforward and built into the libraries you are using. But for LLMs, it is less straightforward, and MLflow has, for example, quite sophisticated evaluation stack for LLMs, where you can also define your own judges and all of that. And there are also other LLM ops specific tools like vector databases, which also is debatable. Is it really LLM ops? Because you could also use vector database for recommendations, for example, right? Where you store your embeddings. For LLM ops, you also see guardrails. So guardrail is an important thing, which also tied to evaluation in a way, because you could just put evaluation in the logic of the agent and it becomes a guardrail. But there are also specific guardrail tools that you can put on top of your system or on top of your LLM call. AI gateway, human in the loop. These are also important parts of LLM ops stack, because for AI gateway you want to have fallbacks for other models, rate limits, and things like that. Human in the loop is also important for really complex processes, and it's not always straightforward how to build it in the system. And you need something for memory store usually for LLM ops. I think now I kind of went through all of the tools I could think of, all the groups of tools. It's a lot, and learning all of that is really, really complicated, in fact. And MLOps is not really for beginners, in my opinion. It's complicated.
No, I mean, that was great rundown of how the stacks look like, right? So what I felt from that conversation is like LLM ops or ML ops, it's just the framework that you organize your stack. Each is serving a different purpose. Like data is data versioning, like memory and all the stuff that you mentioned. And you have to make sure that framework, the ops principle, makes sure that everything is happening. Whatever sequential nature of work needs to happen, it will happen by the scheduling jobs. Where parallel things need to happen, it will happen. So I think it's all about giving you the controls and those buttons to make sure all the principles are operating the way you want, right? So I think it's a great framework. And you did point it out about LLM, so it's a good segue for my next topic that I wanted to cover. Is like, today I talk to folks, and we do see a lot of the great proof of concepts, demos, all the time, right? So when it comes to AI, but when the challenge comes, I think there was a paper published some time back, was 95% of these things only remain on the prototypes, right? It's not moving forward, and there are various reasons, but the majority of the reason is missing this kind of implementation details. How do you take these prototypes into production, right? So what are your thought process here? Like, why teams are struggling to take some of these fancy demos to actual production?
Well, there are multiple reasons. I think when we just were starting with ML, also there were many failures because we realized ML is pretty hard to bring in production, much harder than regular software, and you have all these components that you need that you maybe didn't need for regular software. And it took some time to formalize those practices. And I think now the failure rate of regular ML is not that high. Well, that's at least my feeling. Actually, never had a situation, well, in the last years at least, that we wanted to bring something to production and we couldn't. So
Yeah.
or something failed. I think maybe if something would fail, it's more for the reasons that maybe business had certain idea and they thought it would be a good idea. And then you try to, and you deploy it and it's not a good idea. It doesn't deliver the value that you expected it would deliver. So I think that would be one of the reasons, really. With AI, I think we are missing formal processes still because it's really new domain, and also the ways how you could bring it to production changes. The tools evolve so much that I have a chapter in my book on LLMOps, bringing agents to production, and I rewrote it like 4 times, a lot.
Keep changing.
It's a code heavy book, which has its benefits, but also comes with these kind of problems. Yeah, I just wanted to make it for practitioners, but
Right.
the fact is things change a lot. Also, what you see that a lot of software engineers are on those projects. And as I said, I think it's easy to deliver like an agent, but to actually make it work in production is hard because it comes into this evaluation stack. And that's type of knowledge that those people usually don't have. And you really have a steep learning curve there
Mhm.
to make it really work and monitor those things in production. And that's what we've been doing for ML for many years. So we are pretty much familiar with these processes
Right.
around it. And also, I think that's another part which we also saw when data science became the sexiest profession of the century. Did not last that long. Yeah, we also saw that everyone was really pushed to do data science where it didn't even make sense because it was cool and sexy and everyone wanted to leverage their data and get the value
Right.
out of it, where just simple analysis maybe would do the job, right? Now we see the same with AI. We want to apply AI for everything, even where AI doesn't necessarily make sense, just because teams have big budgets and they get these budgets allocated if they do AI. We see also the same with coding tools. You get, yeah, well, you get praised for using a lot of tokens, right? And then
Yeah.
you
Yeah.
see that teams start using AI for things that don't even make sense to use AI for. So these kind of incentives are kind of weird. And that's also what we see, I think, that everyone is just trying to do something with AI. And those things don't just make sense sometimes. And
Yeah. Yeah. That's
it
a
will
big.
stop.
Yeah, that's definitely a big take, and I agree totally because AI is powerful and had a potential lot of use case. Doesn't mean that every problem we have needs to be solved with the AI. And
Yeah.
one of the example like I used to give is like the tool might work. I mean, it's not that it won't work, but is it overkill, underkill? You need to figure out all that part of it, right? Like
Yeah. No, for sure.
you can break a peanut with a big hammer. Doesn't mean you
Yes.
should all the time.
Yeah. No, for sure. And but I do see a lot of benefits in that, though. Of course, we probably waste a lot of compute and a lot of
Yeah.
money on things that don't matter. But what we gain from it is that we actually start defining processes where they were not defined well.
Yes.
And because you need such a process if you want to use an agent, and that's even where we don't see the value immediately. The
Right. Right.
fact that we define processes finally, that makes a big difference.
Yeah. Yeah.
So yeah, that's a great upside of this whole story.
Yeah, that I agree because someone always gave me example that you first need to build all the pipes and run the water. You may run something else later, but you have to check it, right?
Yes,
If everything flows, everything works, and may
exactly.
not be the strong use case now, but you are in that direction at least to adopt AI, right? So that's a
Yes.
plus. All right. So switching a gear a little bit, as a data and AI leader, what do you feel like having to build a strong ML team? Like, what are a few things in your mind? Like, hey, if there is a startup or if someone is thinking about, hey, let me ramp up and build a strong ML team. in today's AI world where I can solve the challenges, not only the data science mindset, not only ML engineering mindset. So, but I want best of everything, in one team. So, what could that team
Yeah.
be?
Well, I think it's really, really challenging today because the whole field is changing so much because of this for the AI assisted code. What you can do today with AI, with Cloud Code, it's just mind blowing.
Right.
And I think it is important for the teams to be AI native in that sense, right? That
Mm-hmm.
they actually do use AI professionally to develop whatever they are developing. Either it's just regular software or agents or ML models.
Mm-hmm.
So I think that must be a kind of a prerequisite today. And it doesn't mean that you are using just the chat window just as a Q&A kind of thing.
Right.
So there are also really best practices that are already being established today, how to do it well. How many people you need in a team, that's also kind of, I'm not sure anymore, because in the past it was pretty much well defined. You need some ratio, some seniors to mediors, juniors, and
Mm-hmm.
there was some kind of pipeline of how that would work and look like within the team. Now it's kind of complicated because I think I am probably more efficient doing things alone sometimes with those AI tools. And that's kind of a weird feeling that I never had in the past. So I don't know how to approach it right. Honestly, I don't have the answer for it because I do think we need juniors.
Right.
We do need to educate the new generation of people working in software. And it is still really important on how to architect things well. So I think everyone needs to learn architecture first today, and also the principles behind it. That matters a lot. And formalizing those principles in Markdown files. So
Yeah. Yeah.
write it somewhere that it's basically getting translated into anything that the team does. And this, we call it agentic way of working. That's also what we are really promoting as our consulting company. We basically promote that everyone needs to do everything with AI, even like tickets on Jira ticket or
Right.
whatever tool you are using, and that everything should be moving there, and that should be seen as a source of truth, because you are developing not anymore for humans but for humans with agents, and that's a whole different story. Yeah, it's interesting times really we live in, and I think that also becomes much easier if the board or there is a single source of truth that is populated, to see how that is evolving across the teams and how teams are collaborating together. So I think that's an angle we want to push for, and that's what really makes a difference in the whole transformation in the organization.
Yeah. Yeah. No, I think you said it well. I think there is no right or wrong answer here, and it all depends on you're building it, what are your priorities. A lot of things come in play, but you did touch a really good point about the value of still the junior engineers, what they can bring to the table, and then ultimately the foundations still matter, and that's another key thing that I grabbed from the
Yes.
conversation. Now, switching a gear a little bit, because we are almost coming to end of our conversation, I'll let you speak a little bit about your consulting journey, and now you are starting Couchy or something.
Yes.
Yeah, the name is pretty catchy, actually. And
Yes, it's
tell us a little
indeed.
bit about it. What is it and what you guys do?
Yeah. Well, actually, I never thought I would get into consulting because I've
Okay.
seen too many bad examples of how someone would just come deliver something that no one else can use, and then they leave and everything dies. I've seen it too many times in my career, and that's what I didn't want to be.
Right.
So that's why I said the pillars that we have are education, strategy, and engineering and best practices together. And that's what we want to bring anywhere where we come. So that's very important for us. Name is actually Cauchy, which is a French mathematician who invented gradient descent. And we thought that's such an amazing name for a consulting company focusing on AI.
It is.
And it was still available. So that's why that's
Wow.
why we chose the name. But I think it's a nice name. Also, a very nice, versatile logo that you can use for pretty much everything.
It is.
Yeah, so it's yeah, we have big ambitions,
Okay.
big goals. So gonna be fun.
Yeah, you go big or go home, right? I wish you
Yeah.
all the best, I think, in your upcoming journey for sure.
Thank you.
Yeah, I've followed like things that you have given to community and now taking the same to, extra step further on your own career to establish something for yourself, which is very commendable. And like I said, best wishes.
Thank you.
We'll close with last thing that you have for the listeners, like anything that you feel like sharing, and then we'll conclude.
Yeah, well, I think in this in these times when you can develop everything with AI, it is very important to focus on the architecture, on the core principles first. And
Right.
it is really important to make time to think, because developing things is really, really fast today. But to develop the right things and the things that actually matter and make sense, you need to invest time into thinking. And that's what we kind of unlearned, I guess, because we are
Mhm.
switching context so much. Yeah. So make time to think.
Yeah. Oh, that's great. All right. So we'll come to an end of this conversation. And like always, this goes super fast. The chat is so interesting.
Yes.
I'm pretty much sure that the listeners will get quite a bit from here. Like the stacks explanation and everything towards your journey was very fascinating and interesting. So yeah, thank you so much for your time today.
Thank
And
you.
we'll keep in touch. I'm looking forward for the book myself. So take care.
Awesome. Thank you.
Thank you.
Have
Bye
a
bye.
good day. Bye bye.